me take this advantage. What we are doing, we are incorporated in year 2017 and we are incubated at IIT Kanpur. So we have extensively work exclusively in the field of air quality. So this includes the services as well as the product. And we also have the research and development team. So in services, we have entire, it's a portfolio of, in air quality forensics, doing the source apportionment studies, indoor air quality assessment, dispersion modeling, receptor modeling. And then on the other hand, we have some patents related to air quality products, which also includes bioaerosol sampler. It's a 4-stage bioaerosol sampler, which is now used in hospitals, pharmaceutical laboratory, and for indoor air quality assessments. So these are some of the highlights which we have. We have obtained some technologies from IITs and other institutions, and we are developing a commercial product out of it. And we are not only present in India, we have a strong base in Middle East, Europe, and now in the African region. So before moving forward, everybody is knows what particulate matter is. So I just wanted to give you a visualization. So you can see here in this picture, this is your human hair, and this is your PM10, and this is PM 2.5. So 2.5 micron, you can't see with the naked eye. So imagine if the hair is look like this and this PM 2.5 is this much smaller. And tackling these, as my previous speaker already said, it is very difficult to tackle the smaller particle. That is absolutely correct. And then when you go down to 1 microns, and then the bacteria range comes into the play. So imagine it is not spherical. So everybody knows the shape of a popcorn. So this particles looks like popcorn. And imagine a lot of bacteria, heavy metals, mercury. If they are present in air, they are sticking it to that popcorn, and we are breathing that popcorn. Smaller the popcorn, better the penetration. So as we move down to the particle size, say 100 microns and up to zero point 0.1 microns, 2.5, you can see the toxicity increases. So that is where these fine particles, especially 2.5 and less than 2.5, they are pretty harmful. So as in the previous lecture, you have seen like Alzheimer nowadays has been linked to, if you go to Google, you search about air pollution and autoimmune diseases. So there's a study conducted by AIMS in the year 2013, and they find a direct relation with the air pollution. It has a harmful effect. It is not only linked to only heart diseases or breathing respiratory diseases, but also to the autoimmune disorders as well. So before, it is just a representation of, things. I'll go into the detail of why indoor air quality matter most, because, everybody on an average spend 80% of the time inside the building. And then the outside pollution in Bombay also, now for last 2 years, there are several reports which are coming out that Bombay is now is deteriorating in terms of air quality. One advantage we have inside the building is that the walls and the structure acts as an barrier. But if you're using any system and outside air is pretty dirty, so you need to take care of the inside building where we are breathing. So we are spending 80% of the time, our children are spending 80% of the time. So in an easier language, what indoor air quality is, if we categorize it as in good or bad. So what if I say indoor air quality is bad, so what are the parameters that defines that is bad? First of all, it is the concentration of pollutant. So we can call it as a contamination. And then temperature and humidity. You feel comfortable when the temperature is somewhat around 25 degrees. So it is recommended that average of 25 degrees, but you can go up to 20 to somewhat in the range of 22 degrees to 30 degrees. So where that at that temperature, you'll feel very much comfortable. And relative humidity should be somewhat around 30% to 50%. Less is also bad because the air becomes dry, and then you have a lot of problems. And more humidity, that is also a cause of problem. So the ideal range of humidity which has to be in the indoor is somewhat around 30% to 50. And this is something very, very important. It is the most ventilation. It is the one of the key thing which defines majority of the portion of your indoor air quality. If the ventilation is poor, you can see no dispersion of pollutants and they cannot go out from the building. That is where we call it as a sick building. It is not only the sick people, it is also the sick building. So you need to do various changes where you can put, if there's a lack of oxygen, so your ventilation system should be smart enough to put the oxygen inside the building, and then dilution of these pollutants will take place. So these are the three main things. Biological contamination also comes under the concentration of pollutant. So you can see the important thing is mold, and this is directly related to so many things because mold, once it gets suspended into your indoor air, it is recirculating and you're breathing, and they give rise to fungus generation and all those stuff. And it start off with the headaches. Straight away, if you find you are not comfortable in the building and you have headache, so this can be a possible cause, which can be easily, it is you can go and see with the visual inspection, you can identify it. So this is just to give you a feel how much like we feel, okay, we get the best beds, best paints, things like that, but they all are contributing. They are one of the prominent sources of indoor air quality as well. So we can see boilers, NOx, CO, surface deposition or pollution, gas stoves, it gives you VOCs, NOx, even nanoparticle range PM. Cleaning products, what we are using like Harpic, other cleaning agents, they also gives you a lot of VOC. So you can do a small experiment. You can buy a 5,000 monitor from Amazon and put it inside. This gives you TVOC reading, and you just immediately go outside, you can see a reduction in VOC levels. So once you are maintaining the temperature of somewhat around 25 degrees, this particular pollutant is tend to sustain. So this is just to give you a feel when you are planning something HVAC system or any intake system. So please remember, if this building is near the road and you have an intake here, then what you are doing, you are just extracting the pollutant from this road and putting inside the building. So you need to be very careful. This is just a very small step which doesn't require anything when you have any additional cost when you're planning for HVAC or things like that. So you need to make sure that you are taking the air from the cleanest point of the building. It may be upside, it may be on this side, that side, but not on that side where the contamination are pretty high. What are the consequences? Health effects, everybody knows. Economic impact. This is something very, you can say a broader term. If you want a specific number, nobody can give it to you. What are the economic impact? But this is well established. Healthcare costs, since you are residing 80, spending 80% of the time inside, it creates a direct impact on your health. And that is where the healthcare cost comes up, and you lost productivity. You're with the age, and if you are inhaling a lot of pollutants, then you lose the efficiency of your organs, and then that is where the loss of productivity comes into the play. So what to do? Simply we identify, eliminate the source of contamination, provide adequate ventilation, add or remove air contamination with dilution or contamination with fresh air. So these are the few things which we can do. And then nowadays, with the increase in air pollution, everybody talk about filter and things like that. So but it is not only all filter that gives you the good air quality. Now HEPA is one of the best categorization of membranes where you can get somewhat around 99.99% of particles, but it is also incapable of removing zero point 0.3 microns of particle, less than zero point 0.3 microns. But this is pretty much acceptable to us. And then a new thing which has also come up is the ULPA filters. So it goes up to 0.1 microns. HEPA goes up to 0.3 and ULPA goes up to 0.1. And then various manufacturers has to see which filter they wanted to use it, and the pressure drop and things like that they would assess and suggest you which one to go. And this is some international standard. I'll pass on this slide anybody. So I just wanted to put in front of you, if somebody says you, if any manufacturer or anybody comes to say, oh, I have E10 class of filter, so until unless we are not aware of what they are talking about in terms of technical language, it's pretty simple that you can see. If somebody says ISO 15E, that means greater than 95% of the efficiency. Great. So this is just to give you a feel of the membrane classification. And nowadays, new technology which people are saying electronically charged, that is also coming, which basically works on the electrostatic principle. So if you're planning something, any control measures in the indoor air quality, and then you have these two options. One is the filtration based upon the membrane based, and another filtration based upon the electrostatic charges. So there's a huge pressure drop, electrically charged particle. And the best thing with the electronically charged filter is that you can take it out and you can just wash it, and then you can reuse it. So although if there's a problem of pressure drop, but you're getting a good efficiency at somewhat good efficiency, and that too, you have to see your economics. So the capital cost of electrically charged filter may be high, but the running cost is pretty low. But in case of mechanical filter, you have a better efficiency, but you need, once you use it for 2-3 months, you need to replace it. The replacement is the only option. So the another thing which I call it as a smart ventilation. So nowadays, many people have come up with the commercial solution which are saying we will give you the good indoor air quality. And it is not only, when I say indoor air quality, it is not only confined to the pollutant. It is also related to your thermal comfort, which I already talked about the temperature and the humidity, and also the noise. It is also a kind of pollutant, but if you're doing something, then you can also opt for these two things to make you comfortable in the building. And your smart ventilation should be capable enough to minimize your energy cost, because this is the cost which is going to be the recurring cost. If we talk about the economics, obviously, the capital cost, which is the very first cost, designing, purchasing, installing, and the ventilation system. This is the direct cost, and then you have the indirect cost in terms of energy. So now the market, if somebody wants to do something in the indoor air quality and all, so you can see the huge market in terms of Southeast Asia, as well as in the some US part in indoor air quality, where China, they have they have the 47% share in the entire air quality market. And then you can see India is among the sixth number. We are also trying to develop some indigenous cost effective solution. And then this is the market size. It's $1 trillion market. This air quality market is going to be $1 trillion by 2030. This is a report of International Trade Administration. So but somehow these Chinese, these Americans, and the European, they are coming into the India, they are capturing our market. So there is a need that is one of the biggest market would be available by 2030. So one can start off something and provide a good air quality in the cheaper prices to the Indian customers. Like people like Delhi, they are suffering like anything. Now the air purifiers sale is pretty high, but it is not that you put one equipment. You also need, it has to be customized solution based upon your building structure. And you have to come up, I request, not only the instrument, it is all together, customized solution that should be provided to Indian client. That would be much helpful in that case. So we have a big market. I hope people will come into this market of indoor air quality and boost the economy and give the people the good air quality.